So lesson 5.1 is broken into a 5.1 part 1 and a 5.1 part 2. And it's going to take us a little bit of time to get through, because what we start doing is we start looking at these fundamental trig identities. By the end of the chapter, we're going to have a whole page of just identities. This right here is, probably about half the page, but we're going to add more identities as we go. And these are different identities that we can use to solve problems or simplify problems that have trig functions in them. Some of these things are going to look familiar. We've hinted at, talked about. Some of them are going to be brand new. They're all going to be ones you need to familiarize yourself with. Okay, so as we look at some of these, we have the reciprocal identities. The reciprocal identities should be fairly familiar. How's that for saying it? Not that we've expressed them like this, but you guys know, what's the reciprocal of sine? Cosecant, yes. Remember, sine and cosecant go together. They are reciprocals. And so right here, sine is reciprocal of cosecant. Well, remember, a reciprocal is taking a fraction and flipping upside down, yes? So the reciprocal of sine is 1 over cosecant. Or the reciprocal of cosecant is 1 over sine. And so that is a way to change, like from sine to cosecant or cosecant to sine within a expression or a function. Reciprocal of cosine we know is secant, and reciprocal of tangent we know is cotangent. So those are your reciprocal identities that you'll use quite a bit. Okay, quotient identities. We've talked about these a little bit. Tangent is equivalent to, and at the time we talked about tangent being y divided by x, right? So tangent is sine divided by cosine. If tangent is sine divided by cosine, then cotangent is cosine divided by sine. Again, these are ways when we need to be able to change things out that we have those. Now, these guys are new, Pythagorean identities. However, they're big ones. We will use these a lot, okay? And I'll give you hints, about using them. So sine squared theta plus cosine squared equals 1. 1 plus tangent squared equals secant squared, and 1 plus cotangent squared equals cosecant squared. You want to become familiar with those. We'll use them a lot, and they can also be manipulated, right? You can move things across the equal sign, add and subtract to rearrange them. Okay? Our cofunction identities. Everybody has one. Sine of pi over 2 minus theta is equal to cosine. You'll notice the same is true for cosine of pi over 2 minus theta is equal to sine. And this is related to the fact that sine and cosine, if you recall, they're the same graph, yes? Just one of them is scooted over pi over 2. So they're just different by a pi over 2. Well, sine and cosine are related that way. Tangent and cotangent are related that way, and so are secant and cosecant. Now, while we're here, what's another name for pi over 2? What is it?
90 degrees.
90 degrees, yes? Pi over 2 in radians is 90 degrees in degrees. And I only say that because you could also see this written in degrees, yes? You could see sine of 90 degrees minus theta. We'll realize that that is equivalent to cosine then. And then the last set we have are even-odd identities. We've talked about even and odd functions. Even being something that is symmetric across the y-axis. Odd being something that is symmetric across the origin. We've done that at some point. Would have been first semester. Okay? And we talked about those. Well, because based on the symmetry, these relationships exist. The sine of negative theta is equivalent to negative sine theta. Okay? Sine is an odd function. Okay? Tangent is odd, cotangent is odd, and cosecant is odd. So they all have, like, the negative theta is equal to the negative function. Cosine and secant, they're even functions. And so cosine of negative theta is equal to just positive cosine. Same thing with secant. Okay? So those are, again, even-odd identities. These are all things that we can take pieces and swap them in and out. And that's what we're going to practice doing. Okay? Noted here. The idea with the identities is that trig functions can be replaced with other equations that they are equivalent to in order to simplify or solve. So that is a key piece of information there. We're going to try some. You have these at the top of your paper, yes. You'll want them beside you when you're doing homework. I'm going to tell you that right now. Let's look at example 1. It asks us to find sine of theta and cosine of theta if tangent of theta is 5 and cosine of theta is less than 0 by using the identities rather than reference triangles. Okay. So we're being asked to find sine and cosine. Tangent is 5, cosine is less than 0. So yes, we've done similar problems to this before, but we're not resorting to our chapter 4 methods. We're learning new methods. Okay. And so we have to look up top for ways that tangent can connect with other functions. Okay.
Is it the quotient?
Okay, let's get it out of the way now. So the quotient is the common wrong answer. How's that? Okay. Someone's got to say it. We've got to get it out of the way because you guys are all thinking it, right? Because if you're trying to find sine and cosine, they give you tangent. It seems, oh, that's the way to go, isn't it?
That makes sense.
I know. But here's the deal. Unfortunately, it's not, okay? So we've got to, that method, I see the method you're trying to go with. It seems like it should work, but it doesn't, okay? And that has to do with the fact that tangent is equivalent to sine over cosine. Well, we don't know.
We don't know either one.
I mean, we know what tangent is, and I get you can make it a fraction, but it doesn't work that way. Okay, that's not a proper use of the quotient identity. Okay. Huh? We do want to use a Pythagorean identity. Okay?
Oh,
Now, so we are going to use the Pythagorean identity. We know tangent, yes? So we want to use something that has tangent in it. I get it. The only other piece it has in it is secant, but once you know secant, if you know secant, what else will you know? Cosine. So you see where I'm going with this? Okay.
Use the quotient identity.
Then
No.
whoops.
Then you would just use the other Pythagorean.
Then we'll have a couple of different options of how we finish it. Okay? As in, you both are correct. Okay. So, I'm going to write out, what did we say we're using? Which way is it written up top? I forget.
1 plus tangent squared.
1 plus tangent squared of theta equals secant squared of theta.
I do what I did.
You threw a variable in there. It works.
You'll have that.
I'm going to go with theta, though. Okay. So, now what we know is we know tangent, yes? And what do we know tangent to be? 5. If tangent is 5, then tangent squared is 5 squared, or 25. So I'm going to write this as 1 plus 5 squared equals secant squared of theta. Yes?
Yes.
Okay. 1 plus 5 squared is 26. I'm going to flip-flop this. Secant squared of theta equals 26. Thoughts of what to do, or do you need a hint?
I'll take it.
Well, divide 26 by 6.
Squared.
You got that squared?
If this equation, okay, here guys, if this equation said x squared equals 26, what would you do?
Square that out.
Not square it, but
Square root.
square root it.
Yeah, you know.
Okay. Now, so this is, instead of x squared, this is secant squared. So we are going to square root it. The square root, and I don't know if you want to write this in or not, but we are going to square root. The square root of secant squared theta is going to be secant theta. What's the square root of 26?
Square root of 26.
Square root of 26 sounds like an awesome answer. What do we need to throw in there?
Plus or minus. Oh, sure.
Officially, we need to consider the positive and negative options. It's not both. It's just one of them. We have to legitimately decide, is secant of theta positive square root of 26 or negative square root of 26?
Negative, because it's less than 0. Negative, because it's less than 0.
Cosine theta
Makes sense to me.
is less than 0. That is fancy code for cosine theta is negative. If cosine is negative, what else must be negative?
Secant.
Secant, because cosine and secant are reciprocals. So for that reason, we're going to say that secant theta is negative square root of 26. Make sense? Now, all that work, and that's not really what they asked us for, but can I find one of my answers now?
Yes.
What do I know?
The reciprocal is the answer.
Reciprocal is the answer. So, and officially, what are you going to tell me cosine is?
1 over the negative square root of 26.
Okay, 1 over the negative square root of 26. And that's perfect thinking, okay? That's perfect thinking. If you want to officially use that reciprocal identity, the reciprocal identity says that cosine theta is equal to 1 over secant theta. And so if I fill that in, cosine theta is equal to
Negatives.
1 over negative square root of 26.
Can you just leave it like that, or do you?
You can leave it like that. We don't do a lot of rationalizing with what we're doing right now. So enjoy it. So you understand the point of, you didn't actually have to write out the reciprocal identity there, did you? I mean, that's known fact, and that's fine. Okay, we've answered half of this problem. Now we need an option of how we want to find sine. And I know you guys kind of already mentioned things, and there's not just one right way to go here.
What would
Okay?
be the easiest way to go?
What would be the easiest way
Yeah,
to go?
I don't have an answer as to what would be the easiest way to go, because neither of them are that much more difficult. So one option is Pythagorean theorem, Pythagorean identity. Which Pythagorean identity would we use now?
Sine
Squared.
Sine squared plus cosine squared equals 1, because we could plug cosine squared in and get sine squared. Okay, what's our other option? Can we use the quotient identity now? Yes, because we know 2 out of the 3 pieces of that. Now, I think I'm actually going to go with the quotient identity here. But if you want to go with the Pythagorean identity, I mean, they're both good. Neither one is better or worse than the other, if that makes sense. Okay? So I'm going to go with the idea that tangent theta is equal to sine theta over cosine theta. I'm copying these straight from the top of your notes, yes? They're not crazily coming from anything else. So now, fill in what you know. Tangent is 5. Sine, I don't know yet. And cosine is negative 1 over square root of 26. I just put the negative out front. Okay? How do we solve for sine?
5 times negative 1 square root.
Yeah. If it's sine divided by that, we need to multiply by that. So I'm going to say that sine theta is going to be 5 times negative 1 over square root of 26. No calculator necessary, because I don't want a calculator answer. Your calculator is going to go decimal, and I don't want a decimal. What is 5 times negative 1 over square root of 26?
Negative 5 over square root of 26.
26.
Negative 5 over square root of 26. If anyone happened to try the Pythagorean identity, you would end up here eventually. I do think, in retrospect, this one was easier because with the Pythagorean identity, in this case, in Pythagorean identity, you would have had to worry about common denominators and stuff.
So there will be times when Pythagorean identity is probably easier to do this.
Just depends. Okay. And that's where you're going to learn real quick. There's not just necessarily one right way to do these problems. Different people might get to the answer in different ways, and that's fine. This is not a big calculator section, really. It's more about how do we manipulate these identities. And once you start seeing them, they're pretty easy. The key is being able to see them. And that takes a little practice. Okay? Are we good there? Okay. Example 2. Given that cosine of theta is equal to 34 hundredths, find sine of theta minus pi over 2. Start checking out your identities and see if there's anything that strikes you as we might want to use it. Okay. And I will say, okay, so we're given this, we're trying to find this. What strikes me right here, that theta minus pi over 2. Did we see something up there? Now, what's the catch? It's not exactly it, is it? Okay, it's flip-flopped. So it's close, but it's not quite there. But it's still, we're going to use our cofunction identities here. Okay, and I'm going to tell you, because so this is like one of these things to look for. Anytime I see a pi over 2 minus theta, or theta minus pi over 2, or swap out theta with some other variable, or swap out pi over 2 with 90, I'm immediately going to go think, okay, I've got to use my cofunction somehow. Maybe I don't know how, but I've got to use my cofunction somehow, right? So we're going to use the fact, which way was this one? That sine of pi over 2 minus theta is equivalent to cosine of theta. And I'm going to write this down off to the side that I just need it on this page in front of me. Okay, that's from up above, yes? You guys have it on the same page. It's just on a different screen for me. Now, as I said, the trick is that it is slightly different, isn't it? And I have to think, which way do I want to explain this? I always struggle with which way to explain this because it's just kind of there in my head. Like I can just see it, I just know it, and it's one that I struggle with. So okay, so let's go with what are we trying to find? We're trying to find sine of theta minus pi over 2, yes? But the problem is that theta and pi over 2 are in the wrong order with the wrong signs, yes? So I'm going to take a baby step. I'm going to flip my order. I'm going to say that this is sine of negative pi over 2 plus theta. Correct? Nothing fancy. Now, we're going to think about factoring a negative out within that parenthesis. When I think about factoring that negative out, it's, how do I want to do this? A negative, and when I factor out that negative there, there's a positive pi over 2, and then it becomes a minus theta, correct? Yeah. I know, it looks weird, and I don't know, maybe the baby steps make it more confusing, but now here's the deal. We have sine of a negative quantity. Officially, because I know some of you are like, oh, Mrs. Sargent, why did you just put that negative out front? Well, it depends on which function we're talking about. If you go back up top, right here, sine of a negative variable is equal to what? it is equal to negative sine. So we can just essentially put that negative out front. Had this been cosine though, it'd be positive cosine. Okay, so that's why I'm drawing your attention to right here. So I can take that negative out there and say that this is the negative sine of pi over 2 minus theta. Now am I officially there in that we have a negative, but what do you know about sine of pi over 2 minus theta? It is officially equal to cosine, yes? So that piece right there, I'm going to say that this is equal to the negative of, what is sine of pi over 2 minus theta?
Cosine theta.
Cosine theta. And I know, there's easier ways to think through it, but I want to make sure we see the connections. What do we know?
But then it just equals negative 0.3.
Yeah, cosine is 0.34, so if this is negative cosine, this is negative 0.34. And that's because we also knew this piece, right? So we were able to just sub it in. Are there other more direct ways maybe you got there in your own brain? Sure. I don't know. I mean, it's all very quick steps for me to think. But I kind of, basically we used a co-function, but we also used a, what's their names? Even odd identity. Okay. Okay, questions on that one? Okay. Example 3 is more like example 1. Find secant and cotangent if sine is provided and tangent is greater than 0. So I'm being asked to find secant and cotangent. Sine is negative 2/3. Tangent is greater than 0. Where do you want to start?
Pythagorean.
What'd you say there at the end, Hannah? Come back here a
We
moment.
know sine.
Okay,
We know cosecant.
okay,
So the
okay, okay. So, and this is where, and I'm going to be curious to see which one you're thinking.
The last one.
Okay, okay. So Hannah suggested that we know sine. So I would agree, if we know sine, we can say we know cosecant. And so then she suggested we go with the Pythagorean identity that connects
the very last one.
cosecant and cotangent, the bottom one. Is that what you were saying?
Mm-hmm.
Okay,
You could even do the top
okay. So a different option, because that's what you guys are saying, Pythagorean identities. Yes, but which one? A different option, you just mentioned we could do the top Pythagorean identity. If we know sine, we could plug it into the one that connects sine and cosine, and then you're going to find cosine, which cosine will then get us secant. Now, which way is the right way to go? I'm going to say the right way to go is whichever one you saw first, because that's the one that works for you. Does that make sense? Okay, if you see it, go with it. If you're sitting there saying, oh, well, because I'll be honest, who knows what what the students told me at the time? Who knows what I have in my notes I did on my own originally? But I have sine and cosine staring at me. I use that one. But I'm totally, if you guys are seeing that, oh, I know that reciprocal, it connects with cotangent, let's go there. Does that make sense? So, in the end, it'll all work out. Huh?
Is it zero, one over another?
Well, but when we do that 1 over, yeah, I don't know. Okay. I mean, do you guys care which way we go? Are you guys starting with the cosecant cotangent
I
one?
want to do the sine.
So
Really?
yeah.
You just changed your minds? What do you mean? Look, you
We can do
mentioned
whatever your guys' heart desires.
This is 20.
because you just didn't see it. And
Much.
okay. And honestly, it doesn't matter to me. Okay, so go with sine and cosine instead. Again, it doesn't matter, right? That's my point. So sine squared theta plus cosine squared theta. And all this to say, when you guys start checking each other's work and helping each other, not everyone's going to have gone the same way, right? So if I know sine squared plus cosine squared equals 1, I can plug in sine, yes? So sine squared says we're going to do negative 2/3 squared plus cosine squared equals 1. What is negative 2/3 squared? Check again. There we go. Positive 4/9 plus cosine squared equals 1. Get that mistake out of the way now, right? Well, it doesn't matter.
It's been a long
It's actually been a really short week for you too, though.
Yeah,
Okay,
it feels like it's been long.
how do I solve for cosine? Subtract 4/9, right? So cosine squared theta, that's my x, right? That's my x I'm trying to solve for. So we're going to subtract 4/9. So now I have cosine squared theta 1 minus 4/9.
5 nines.
Because what is 1?
9
9/9 minus 4/9, which is
5 over
5/9. We've got that basic fraction piece down now?
Yeah.
Okay. If cosine squared theta is 5/9,
Square root of that.
we're going to square root that bad boy. Square root of cosine squared is cosine. Square root of 5/9.
E squared of 5 over 3.
Yeah.
Square root of 5 is like 2 points.
It's a square root of 5/9.
Yeah.
The square root of 5 is the square root of 5. The square root of 9 is
3.
3. So you can go with the idea of square root of 5 over 3. Officially,
Plus or minus.
I need to say plus or minus until I identify which it is.
It should be plus.
But we don't know yet.
But we don't know.
We don't have anything officially telling me yet, do I?
No.
Okay. Let's see, what do I want to suggest here? I think my suggestion, okay, what do we know up here? Let's start there.
That tangent is positive.
Tangent is positive, and sine is
Negative.
negative. So, I'm going to draw something familiar here.
Not false. False too.
You know chapter 4 isn't done, yes? I told you when I handed back those unit circles, you still need stuff off of there.
Yay.
Okay, all students take calculus.
I think I'm gonna go with quadrant 3 too.
Why quadrant 3?
It's
Because,
the only place where tangent is positive.
well,
Other
that
than-
and quadrant 1.
Other than
But sin is negative. Sine is
So if tangent is positive,
I do that all the time.
okay, so if tangent is positive,
everything else.
we're Xing out those two.
Yeah.
But if tangent is positive and sine is negative,
Cosine has to be.
we're Xing out the all. So cosine is
Negative.
negative. Agreed?
Agreed.
So cosine theta is negative square root of 5 over 3. Does look like I played tic-tac-toe with myself, doesn't it? Just not enough boxes, but does that mean X is 1? They got more turns?
Yeah.
Okay, now, all of that, and I found cosine. And if you want to think about it, I've made 0 progress on my answers. I've made progress, but I still have no right answers.
We
Reciprocal.
can find secant.
Okay, we know secant.
3 over square root of 5.
You guys good with that?
Sorry.
Okay, so now, and I will say, if I use, and I agree, you guys just said, okay, if this is cosine, you're already looking at it, just eyeballing it. Secant is negative 3 over square root of 5. Officially, if I use the fact that secant is 1 over cosine. Let me just demonstrate this real quick, because we're going to have that not fun situation of secant is 1 over a fraction.
And that's
But
you should flip the fraction.
it's 1 divided by a fraction, which means 1 times the reciprocal, yes? And so right there, it's going to be 1 times negative 3 over square root of 5, which is what you guys already said the answer is, correct? Okay.
You have to change that to like rationalize.
My notes do not have things rationalized, and I don't think the homework will either. Okay. What else do we have to find? Cotangent.
Quotient.
Mario seems pretty positive his answer.
Could we use a quotient identity? And this is the same thing as the previous problem, right? You could use a quotient identity, or you could use a Pythagorean identity.
Let's use a Pythagorean.
I
So
think we should use quotient because it's easier. We have both of the pieces to
I guess
find
that's
them.
I say I like quotient for the finishing touches when we have both the pieces. So quotient, what quotient property am I using?
Cotangent.
Cotangent theta is cosine theta over
Sine.
sine of theta. So cotangent is negative square root of 5 over 3 divided by negative 2 over 3. Yes?
Yeah.
Fraction divided by a fraction. Keep, change, flip. So I'm going to keep square root of 5 over 3.
Where did you get to?
It's in, so.
Oh,
Does that answer it?
yeah, I got it now.
This is very short.
Keep, change, flip. I am keeping negative square root of 5 over 3. I am changing multiplication to, or, thank you, division to multiplication. And I am flipping negative 2 over 3 to be negative 3 over 2.
Now you just run those straight across.
Yeah, I do have 3
Over 6.
I would cross cancel
Yeah.
Cross cancel.
because my 3's cancel. So then I just have square root of 5 over 2, negative or positive? Positive.
Hooray.
Bless you.
God bless you.
Sound like a bus.
Thank you. You're not Mario.
No, where did that
You're
even
Noah.
come from?
Okay,
Thanks.
That was
questions then. Okay,
Oh,
so
we're gonna be working on the next one.
When we start looking at the backside, okay, and I don't know that we'll actually work any of these, but I'm going to talk about them. We'll start talking about it. You'll notice at the top of the backside, there are 5 different, I want to say steps in a way, but more like 5 different options to consider. Because this backside is just simplified. How can you clean this up and make it a simpler version? Okay, now, options. If you have 2 fractions, create a common denominator to combine the fractions. Okay? 2, separate numbers by dividing each piece by the denominator. So see, these aren't steps because we're not going to do both of these. That'd be, silly. 3, factor or FOIL. So we might have to factor things or FOIL things. Okay? 4, look for Pythagorean identities. I always say if you see trig functions squared and then added or subtracted to other trig functions or 1, you're probably looking at Pythagorean identity. And then another option is to change all trig functions to sine and cosine. Everything goes to sine, a combo of sine and cosine. And so that will sometimes help you to clean up a problem. Okay? Now, this is a part where it just takes practice. It just takes practice of looking to see what you can find. Okay? There's not necessarily one right way to do them, but there is just one right final simplified answer. Okay, so we will Monday work on doing some examples here of just how do we do this. And that is going to make the homework that's listed due on Tuesday. Now, what is unique about that homework I have listed?
It's
It's odds, which I never do, right? But here's the deal. Okay, yes. I did odds because the answers are in the back of the book. I did that on purpose. Here's what and I'll tell you guys up front.
That's odd.
I usually end up doing the odds, and then the follow-up assignment usually ends up being the evens. Because they take work. They take practice of just being able to see them, if that makes sense. Okay, some of you will catch on quicker than others. And sometimes it's just a certain problem. So the odds will be the assignment due Tuesday. Tuesday we'll probably spend the entire period going over questions, unless you guys are different than previous years and it just is all magically easy peasy. And
Are you not looking?
and if it's really all magically easy peasy, then we might not even do the evens. But usually after I have the odds, the next assignment is the evens. Okay? Yes.
So I have figured for Monday and Tuesday, so you said Monday we're just gonna go over notes and Tuesday over.